Hi, class. This is your physics lecture for Monday, September 21st. I want to incorporate kind of what we did last week, where we were talking about velocity and distance and displacement, and then how to rearrange an equation to solve for a different variable. So I'm going to do a few examples of some velocity questions today. First, let's start off with a review. If you remember last week, we defined velocity as the rate of change of position. Really, I should say displacement here. We defined it as V equals delta X over delta T. Remember that triangle is delta, and that means change of. So delta X is change of position, change of X. Delta T, change of time. And when we say rate of change of something, all we mean is we're dividing whatever it is by time. So we could talk about the change of position, we could talk about the change of distance, we could talk about the change of momentum, the change of energy. All we mean by that, the rate of change, would be we're taking what that change of that variable is and we're dividing it by the amount of time. And so again, the delta, the triangle, means change, and we define delta X as X final minus X initial, and delta T equals T final minus T initial. Now this is important. Make sure you have that sign correct, that it's final minus initial. Otherwise, you're going to get everything backwards when you solve your problems. So let's start with an example. So let's say, Dr. Yates, I was driving from Columbus to Cleveland, and I go up Interstate 71. I get on the highway at mile marker 131, and it's 1 o'clock. And I exited at mile marker 218 at 2:27. What was my average velocity in miles per hour? Well, the first thing I want you to do is to identify the variables and assign values to them from the problem. So let's look at our problem, and what are the variables that we see? Got on the highway at mile marker 131. So there's a variable. So that was the initial position. So that's going to be my XI, my X initial. It got on at 131 at 1 o'clock. Well, there's another variable. That's the initial time. That's when we started. All right, let's keep going. Exited at mile marker 218. Well, there's another value. There's another number. What's that for? That's our X final, right? Our final position. And we have a time again, so that's our final time. So again, also be careful that you make sure you line up your variables correctly. The initial variables, 131 mile marker and 1 o'clock. The final variables, 218 mile marker and 227. Make sure you're making sure that you got the same corresponding things, right? That this at 218, it was at the mile marker 218, it was 227. So those two variables are tied together. Those are the final state. Make sure you don't switch them. So now that we've identified our variables, let's write them down, right? We've got an X. Oh, I'm sorry, there's one more variable here in our equation, and that's velocity. That's the question. It's asking us what the velocity was. So I always want to write down all the variables. So it tells us in our problem we have 5 variables. Right? So we write them down. Let's write down their values from our problem. X initial is 131 miles. X final is 218. Time initial is 1. Time final is 215. And I put a question mark here for velocity, just so it's clear what it is that we're trying to calculate. So we look at our equation and we know that V equals delta X over delta T. So we need to calculate delta X. How are we going to do that? Delta X is XF minus XI. Take our final position and we're going to subtract our initial position from it. So here we go. Our initial position was our final position was 218 miles. Our initial position was 131. So we're going to subtract those two and we're going to get a total change in distance of 87 miles. Change of position of 87 miles. Okay. Well, let's do a similar thing for time. We need to find delta T, or the change in T. That's defined as time final minus time initial. And again, from our problem, we see that it was 2:27 when we finished, 1 o'clock when we started. What's the difference here? This is, 1.45 hours. 1.45 hours. Okay. So now we have everything we need. We can plug it into our velocity equation. Velocity equals delta X divided by delta T. Let's plug them in. 87 miles divided by 1.45 hours. And what are we going to get? That our velocity, our average velocity, was 60 miles an hour. So here I wanted to get you used to looking at a problem, labeling your variables in that problem, making sure you got the initial ones labeled together and the final ones labeled together, and then just list out the variables. Make them in a list here so it makes it easier for you to follow what you're doing, because then you can start your calculations real easy and you have everything right where you want it. Okay? Let's mix it up a little bit. Let's take the same kind of thing, but we're going to solve it for a different variable in the equation. So we're going to look at that same scenario we just did. We're going to tweak it just a little bit. So again, I'm going to say I'm going up to Cleveland on I-71. And we're going to start at mile marker 131 at 1 o'clock. This time, though, I'm saying I'm giving the speed. Right? We drove at 75 miles per hour, and we still exited at mile marker 218. When did I get there to mile marker 218? Again, the first thing I want you to do is identify your variables and assign values to them from your problem. So let's look at our problem. Let's identify our variables and our values. Got on the highway at marker X, at mile marker 131. There's your X initial. And it was 1 p.m. So there's your time initial, just like it was in the first version of our problem. But then it changes a little bit. Here we give you the velocity. Right? So now we have our velocity. We need to figure out what our next variable is. What's it asking for us? Well, it tells us that we exited at position XF. XF. What it's asking us for here is what is our TF? And it looks like I missed putting a TF in here. So let me grab my TF. And let's put it over here. We have our 5 variables, which is good. That's what's in our problem. So let's write them. Now let's, but our problem's worded differently. We're given a different values. We're not asked to find V. We're asked to find TF. So we have to rewrite our original equation. We have to rewrite our original equation. So we need to rearrange it so the average velocity is solved for time. Okay. How are we going to do that? Well, we know that we're going to start off, here's our base equation, V equals delta X over delta T. Well, if we want to get time by itself, what do we need to do? Well, from our notes last week, first thing we want to do is identify the operations that are happening to our variable. Here we're dividing by delta T. That's where our time is. So how do we undo that? We need to multiply by delta T. And we know that if we're going to multiply the right side by delta T, we better multiply the left side by delta T. So after we've done that, what does that give us? That gives us V delta T equals delta X. Okay, simple enough. But we still don't have our delta T by itself. What's happening? It's being multiplied by V. So how do we undo that? What's the opposite of multiplying? The opposite of multiplying is dividing. So we're going to divide by 1 over V to get rid of the V. Got to do the same thing to the other side. What does that leave us for our problem? Delta T equals delta X over V. Now, some of you might be asking, well, Dr. Yates, I don't see a TI or a TF in there. And you're right, because it's buried inside of our delta T, and we'll address that near the end. First, we need to solve for delta T, because that's the variable that is in our equation. So let's write down from our problem, what do we have? We have an XI, we have an XF, we have a TI, a TF, and a V. What does our problem tell us about these? Well, it told us our XI was 131, told us our XF was 218, told us our TI was 1 o'clock. It didn't tell us our TF. That's what we're looking for. And it did tell us our V. So again, we got our equations here. So we need to find our TF. How are we going to find our TF? That means we got to find our delta T first. So let's plug in, let's make this equation. Delta X is X final minus X initial. What does that give us? 218 minus 131. That gives us 87 miles was our change in displacement. Now we can calculate our delta T, because there's nothing to calculate for V. We've been given it. So we use the equation we just rearranged. Delta T equals delta X over V. What's that equal to? 87 miles. We're going to divide that by 75 miles an hour. And we're going to get 1.16 hours or 69.6 minutes. Why am I being particular here? You'll see in just a minute why it helps to convert the hours into minutes. And how do we turn the hours into minutes? We multiply by 60 minutes in an hour. All right, so now we know that delta T. Let's go use the other equation we know for delta T. And that's T final minus T initial. Well, we're going to have to rearrange this one too because T final is not by itself. How do we get T final by itself? Well, we'll get there in 1 second. I jumped the gun on you. Let's plug in the values we were given. TF minus 1 p.m. And we calculated just above here that our time was 69.6 minutes, or 69 minutes and 36 seconds if we take that. This doesn't need to be here. If we take the minutes, this 0.6 minutes and turn it into seconds, it'll be 36 seconds. So now we have TF minus 1 p.m. equals 69 minutes and 36 seconds, which rearrange that. We need to add the 1 p.m. to both sides. So what are we going to get? TF. We do the opposite of that subtraction, means adding. So we got rid of the 1 p.m. on the left. That means we have to add that 1 p.m. on the right. So TF is 1 p.m. plus 69.6 minutes. I rewrote it up here on purpose as 69 minutes and 36 seconds. So we can see that that's 1 hour, 9 minutes and 30 seconds. So 1 o'clock plus 1 hour, 9 minutes and 36 seconds gives you 2:09 and 36 seconds. That's the time we arrived at mile marker 218. So here's a couple things I want you to see here. I really want to highlight as we're going through here. Let me get out my highlighter. Right, we had to rearrange our equation. Right, we started with our base equation. We had to do a couple rearrangements, and we ended up with delta T equals delta X over V. Now note, again, our equation here doesn't have the TF and the TI and the XF and XI explicitly written in it. They're kind of hidden inside of our delta T and our delta X. So since we can't calculate delta T, we can't figure it out just from what the problem gave us. We have to do the calculation. We went ahead and we got that calculation for delta T. And we found out that our delta T was 69.6 minutes. Now that we know our delta T, we can use our equation, our definition for delta T, TF minus TI. We want to get that TF by itself. So we actually plug in our values here. There's our TI, and we got this from right up above, right? Now we add 1 p.m. to both sides. T final plus 1 p.m. minus 1 p.m. They cancel out. We got a 1 p.m. plus the 69 minutes and 36 seconds. We just converted this in here at the end to a time, 2:09:36 p.m. Hopefully this helped a bit, and we'll have some problems in today's folder to help you practice a little bit more. Thanks, guys.